Have you always wanted a set of radioactive metals in your house? Well, now you can get them with the Actinide bundle. This element puts up quite an act. Cool transition. Actinium was first discovered by André Louis Debierne after he separated it from a pitchblende residue left by Marie and Pierre Curie after they extracted radium. Actinium gets its name from the Greek word actinos, which means ray. Because of how rare it is, actinium doesn't necessarily have that many industrial uses. And you might be thinking, hey, why do I want it then? But let me tell you something. If you ever need a neutron probe, you know where to go. Okay, you want some actinium for that. Now there's some pretty cool chemical properties that actinium has, such as its melting point being 1,922 degrees Fahrenheit, and its boiling point being 5,972 degrees Fahrenheit. You also should know that it's about 150 times more radioactive than radium, and it has properties similar to lanthanum. Now you might be wondering, how do I get actinium? Well, you should know that actinium is prepared in milligram amounts by the neutron irradiation of 226 radium in a nuclear reactor. The reaction results in about 2% yield of actinium. Also, another way that you can get it, although it's pretty much never generated this way, is through getting it out of trace amounts of ores. In uranium ore, it contains about 0.2 milligrams per ton, and in thorium ore, it contains about 5 nanograms per ton. Actinium can also be used medically to produce 213 bismuth in a reusable generator, as well as radiation therapy. Some fun facts about actinium are that it's within the top 10 rare elements on Earth, and it was the last element to be discovered in the 19th century. I guess you could say this next element is a bit of a shock. Cool transition.
Thorium, discovered in 1828 by John Berlitz in a crystal later named thorite, named after the Scandinavian god of war, Thor, and the current research is all about nuclear energy. Its chemical properties are pyrophoric, tarnishes in air, and it's radioactive, and most stable in thorium-232. Its half-life is 14.05 billion years. The most common way to separate thorium is by using thorium iodide on a white-hot tungsten filament to create a pure bar of thorium. Thorite and thoria are the most common forms of thorium. To coat tungsten in light bulbs is one of its many uses. Its abundance is 9.6 milligrams per kilogram. The most common source is monazite. You should buy this element because it lasts for a really long time and has a long and possible future in the nuclear energy industry, and very hard to melt when thoria.
This next element is godly.
The third element in our bundle is neptunium. Neptunium was first synthesized in 1940 by Edwin McMillan and Philip H. Abelson in the Berkeley Radiation Laboratory in California. The most common method today to obtain neptunium is through neutron irradiation of uranium in nuclear reactors. Neptunium is named after the planet Neptune, which is in turn named after the Roman god Neptune, or the sea god. The current research on neptunium includes the fact that it can be used to not only produce plutonium-238, but also be used as a nuclear weapon due to its high fission rate. And in 2002, it was first cited that neptunium could create a critical mass. Its chemical properties include its ability to be pyrophoric. It has a Pauling electronegativity of 1.36. It has a density of 20.25 grams at 20 degrees Celsius, and a melting point at 640 degrees Celsius, and a boiling point at 3,902 degrees Celsius. The most current way to purify neptunium is through the Purex process, which includes the solvent extraction of plutonium and uranium through tributyl phosphate, which is then made into neptunium. The common compounds include neptunium-3 or neptunium-7. Its current uses, like stated before, are for making plutonium-238 and the possibility to be made into a nuclear weapon due to the fact that it has a high fission rate, like previously stated, and thus making it a very, very good element to buy if you're planning on destroying the world. The most common source of neptunium today is is through the neutron irradiation of uranium in nuclear reactors, like previously stated. The relative abundance of neptunium is unknown due to the fact that it is mostly synthetic and only found in small elements. Its military role, however, has not been decided yet or used. Either that or the information is classified. But we do know that neptunium can be used as an atomic weapon or nuclear weapon. An interesting fact, however, neptunium is actually the main ingredient in high-energy neutron reading tools. Another interesting fact is that neptunium is found in all smoke detectors, and every year 22 nanograms of the element is formed.
This element sets you free.
Last, and probably least, is americium, or AM-243. Americium was discovered in 1944 at the University of Chicago by Glenn T. Seaborg, Ralph A. James, Leon O. Morgan, and Albert Yorso. It was made by hitting plutonium-239 with high-energy neutrons, forming plutonium-240. And then, plutonium-240 was hit with other neutrons to get 241, and then that decayed into americium. Americium obviously derived from the name of America, where it was named and is placed under europium in the periodic table. And why would you want americium? Well, right now, you can get some big bucks with it because it's currently being researched to be used in spacecraft batteries, medical situations such as x-rays, and to measure different gases in industrial situations. Some facts with americium is that its melting point is 994 degrees Celsius. Boiling point is 2,607 Celsius. It tarnishes in open air, and its pyrofluoric and density is 13.67 grams per centimeter. Since americium doesn't occur naturally, it doesn't need purification or separation since it's solely made synthetically. Americium-241 is the only isotope of americium to have a widespread commercial use. It is mainly used to make smoke detectors. So anybody in the smoke detecting business or alarm business can make some really good money off of it because 1 gram of americium can make up to 3 million smoke detectors for your business. Americium is made $1,500 per gram, and again, is solely synthetically made because it does not occur naturally on Earth. Americium, as first said, was a byproduct, of naturally a byproduct of development of making a nuclear bomb during World War II in 1944. So that's where they played its role in the military. A portable source of radiation is americium to be used in X-rays, so it can be used around that kind of scientific area. And americium-241 has a half-life of 432 years.
The origin of neptunium comes from the planet Neptune, named after the Roman god Neptune, the sea god. Okay, still, keep on recording, don't stop recording. Okay.
Let's see. Yeah.
I thought you said see to God.
Okay. Get it focused. Yes, I'm doing okay. The main source of neptunium, like previously stated, is from nuclear reactors due to the fact that uranium radiates.
I think I might be rare.
We should put all of this in the video. You should put all of this. Like an ending montage of oh my god, oh my god, oh my god.
Okay.